Hello guys, myself Yashaswini. Today I am going to talk about Floyd's Warshall algorithm for finding the shortest path between all pairs of nodes in a graph. So imagine I give you a graph and you want to find the distance, that is the shortest distance between the nodes 1 and 2. You could say that you can go directly from the node 1 to node 2, and then the direct distance, that is the shortest distance, would be 9 because I can go directly from 1 to 2. Now if I tell you there is one intermediate node that you can use, basically you can go from 1 to 0 and then from 0 to 2 rather than going directly from 0 to 1. You could say that I can update the shortest distance between 1 and 2 to a new value which is a minimum of 9, and the previous my value that you calculated plus the value of that going from 1 to 0 and 0 to 2. So that is basically would be, that is the shortest distance of going from 0 to 2. The first one would be 3 and the second one would be 3. Therefore, we are calculating the minimum of 9 and 6, which would be 6. Now, what if I tell you there is yet another node that you can use? It's still between the path 1 and 2. And now that you can use this one, I can say the distance can now be updated to the previous distance, which is 6 plus the shortest distance of going from 1 to 3 and from 3 to 2, and the shortest distance going from 3 to 2, its value would be 4 plus 1. Then the minimum of 6 and 5 would be 5. Therefore, I can go from 1 to 0 and then from 0 to 3 and then 3 to 2 at a cost of 5. So, I can sort of give you no node, that is no intermediate node in the beginning. So, you can say I can go directly from 0 to 1. And then now we are allowed to use only one intermediate node between 1 and 2. So you can update your distance to 6. So I gave you 2 nodes, and then you can say, hey, I can update this value to 5. In the extreme, I can give you allowed, and I give you that you are allowed to use all n nodes as an intermediate nodes. Therefore, you can use as much as your freedom. Therefore, we repeat this from 0 to 1 to 2 and then to n. The shortest path at the end should be the actual shortest path between 1 and 2. I can generalize this and say the shortest distance between all I and j using the chain first nodes is shown by d of I and j and k, a function with 3 parameters that shows the shortest distance of going from I to j using the first k nodes, and then I can generalize the moment that I'm adding the k's, and I can say whenever you are adding the k's node, if you are comparing the case of going I to j with only k minus 1 nodes to the case that I go from I to k first using the k minus 1 nodes, and then I go from j using k minus 1 nodes, and then I generalize this minimum, which minimum value that takes the path, the direct path between I and j using k minus 1 and then I minus j plus j minus j, and I can sort of come with this recursive value. If you notice, the d of I, j and k now depends on the I, j and k minus 1, d of I, j, k minus 1 and d of k, j, k minus 1. So each time the k depends on the value of k minus 1. All right, so now let us see an example. So this is a graph, is a bigger graph, and the first thing I do is to create a matrix that shows that the h value stick weights between each I and j. For example, between 0 and 1 the h value the braid is 3, so 0 to 1 I put 3, and I do this for all the edges, and I put 0 for all the folded, and I represent the distance, the shortest distance between each node to itself. So 1 2 1 2 1 1 and would be 0, and then if there is no node and if there is no edge between two nodes, for example between 0 and 3 there is no edge, so I can put an infinity to represent that. So this matrix is the initial matrix, is the direct translation of our graph. We haven't calculated anything yet, and let's write our recursive function that we just came up with here, and I am showing you on the left bottom of the case that you are not allowed to use any intermediate node. There we start from now. In this graph, if I tell you, you are allowed to use node 0 as an intermediate, and there are certain nodes that 0 is between the path between I and j, is on the path between I and j, which we can update. For example 1 and 5 there is no, so the no edge, so the path, the shortest of the 1 and 5 was infinity. Now using when we are allowed to use 0, the shortest path between 1 and 5 is going from 1 to 0, 3 going from 0 to 5, 1, so the value gets updated to 4. There is no more update that we can do, which is node 2 to 5 2 used to be infinity. Now I can go to 2 to 0, then 0 to 5, then that would be 11. And remember, so far we are only allow you to use node 0 as an intermediate value. Now I repeat this one more time. So with this new node, I am not allowed to use node 0 and 1 as intermediate values, and this way I can go through all I and j and see what are the values that I can update. For example 0 to 2, I used to go from 0 to 2 by 10, but I can go through 1, so 0 to 1 and then 1 to 2, that would be 9 rather than 10. Let's look at one more case, which was 2 to 5. It used to be 11. Now if I can go from 0 to 1, 2 to 1, and then to 0, go to 0 to 5 for the cost of 6 plus 3 plus 1, which is 10. So I can keep doing this and then use the new nodes each time, and once I use all the nodes, this matrix will get the shortest path between all I and j, and this is the that inside of Floyd's Warshall algorithm, and there is no other trick to get the shortest distance between all the pairs of nodes, so that we can add intermediate nodes one by one and update this matrix. This is a translation of the formula. So this is how we do Floyd's Warshall algorithm. So thank you.